Hey everyone, welcome to the first PyData Sydney meetup of 2022. So my name's Pavan and I'll be the MC for this month's event. So just a bit of like the event plan for PyData Sydney. Our schedule is generally every second Thursday, every second month, and we have roughly 5 events a year. So we'll have February, April, June, August, and October. And we do have a few placeholder events on meetup.com already. Where possible, we would like to have on-site events. Regardless of lockdowns, we will be providing an online portion for some of these events. And we also have a bit of an online engagement, which will be done through the YouTube live chat, which I'm assuming how everyone's watching this event at the moment. And we also are building a bit of a community on the PyData Slack channel between events. So we do have a bit of a code of conduct. So just PyData is dedicated to providing a harassment-free meeting experience for everyone. So really just be kind to others and behave professionally. We just want to say a quick thank you to our sponsors, NumFocus, as well as Intellify. We also have a few volunteers which do help us make sure these events happen on schedule. So Josh Peak, myself, Pavan, and Kale Temple. So in terms of social media, where you can find us, where you can follow us, we're obviously on meetup.com, PyData Sydney. We're on Twitter. We're also on LinkedIn, YouTube, and Slack. So the link to the Slack channel you'll find in the meetup event. So how can you help this meetup just to grow and share knowledge? You can join as a presenter, so you can give a talk. Even once a year is a pretty big help for us. So our meetup page has a Google Forms if you want to contact us with an expression of interest in giving a talk. You can help us as a guest, share and promote these events, and even attend. And obviously, you can help as an organizer as well. Usually, we need about 2 or 3 different organizers per event. So in terms of how you can help as an organizer, you can coordinate and mentor some of the speakers, trying to getting their presentations together. You can promote the channels on our social media, help with the live streaming, as well as host and emceeing, which is what I'm having a go at today. We have in-person events coming soon. We'd like to kick those off again. We did put a pause on it, obviously due to COVID. So generally what we're looking for are like sponsors and volunteers for food, drinks, and venue. We're after another 2 or 3 different volunteers just to help out with in-person events. So if you're interested in helping out with the in-person events, get in touch with us on Slack. So without further ado, I'd like to welcome Sam, who will be our presenter.
Miss Samuel. It's funny that we still have to do this, but we have to be safe and health conscious. I usually love the face-to-face presentations, but we just have to adapt to the situation as it is. The title as it is Helping Pandas with Pyjanitor. The whole idea or the main crux of this presentation is Pandas is a wonderful tool. It's amazing. It does a lot of things well. Pyjanitor is here to help in some ways to make your code a bit more easier to understand, a bit more maintainable as well. All right, so the outline is a bit about me. What is Pyjanitor? Why Pyjanitor? Some examples, a peek at some functions, and then a Clarion Call. So the bit about me, I'm a core dev on Pyjanitor. I'm also a contributor to Data Table. So if you're familiar with the R language, there is this super fast version there called data table. It's an optimized version of the data.frame. So Python has a part of it, the same way R has janitor, and then you have Pyjanitor in Python. I'm a senior engineer at Slalom Australia. We're a consultant firm. We're hiring. We're primarily involved in business transformations that involve technology. So whatever will make your business lean, fast, and efficient, we are up to the task. We are recruiting. Please visit our website if you feel you have what it takes. No matter what it is, just visit the website, submit your resume, or you could have a chat with me at the end of this presentation. I can get you in touch with somebody in HR so you can have further conversations and see if Slalom Australia is a good place for you. For me, it's a wonderful place so far. I have a place where I blog. I haven't blogged in a while, but this is where I have dumped a lot of my thoughts. And I am a big fan of tennis and soccer. I play them. I haven't played tennis in a while. I play soccer almost every weekend, but tennis I haven't played in a while. It's hard to do the individual sports compared to soccer, which is a bit ironic. Okay, so what is Pyjanitor? As I said earlier, it's an implementation of Janitor in R. The whole idea is to present a clean verb-like API for cleaning data. It doesn't do anything exceptionally fantastic. All it does is wrap Pandas functions into a chainable form. The whole idea is it should be user-friendly, it should be easy to use, and if you want to do a cleaning or if you want to do a data transformation, just dip your hand into Pyjanitor's functions, use it, walk away. Method chaining is a key aspect of Pyjanitor. Be able to look at something and say, Jack went to this place, he picked up a book, and on and on and on. It makes it easier for you to read, and it's a bit easier on the mind in terms of cognitive processing. Now, why Pyjanitor? Pandas is already there. It does the job. Pandas is a fantastic tool. So why do you need Pyjanitor? Data is wild and messy. We know that data is never really clean. If you've dealt with Excel files or if you've downloaded data from the internet, you have a good idea of what this means. If you need results for your machine learning or your dashboards or for your data analysis, you need clean data. It's unavoidable. The catch about data cleaning is it's boring. I haven't seen anybody that comes out and say data cleaning is fantastic. I love it. I can't do without it. We would rather just jump straight to the results, the fancy dashboards, or the machine learning that tells us we'll be millionaires tomorrow. But you need a data cleaning part to get the results. It's intense, it's repetitive, and it's sometimes annoying, but you have to do it. So the whole idea is if you're going to do this cleaning, it should be intuitive, it should be easy to remember. 6 months from now, I want to be able to look at a process and say, oh, okay, this is what I did. I might not be able to understand 100%, but yeah, this is what I did. This is how it works. I can look at the names of the transformations and say, oh, this is what it does. So most likely means this. And that's where you have to document your solution. So if you can make your code part of the documentation, it makes it easy. Now, again, Pandas has a lot of functions. It has about 200 functions. You could easily write your own helper functions, or you could use Pyjanitor, which has a lot of functions that have been tested. So we use PyTest and hypothesis in the library. What is not messy data? This is from Hadley Wickham's description of what tidy data is. So a data that is not messy is where each column is a variable, every row is an observation, every cell is a single value. It's taken from the knowledge in terms of SQL, how you present data, and it's clear, easy to manage. Any other thing that is different from this is a messy data. And I would love us to keep this at the back of our minds when we're going through some of the examples. All right, so let's get in the usual culprits: import pandas, import janitor, and then import numpy. So the very first example we're going to look at is an Excel file. Excel is ubiquitous, it's unavoidable, it's going nowhere, it's easy to use. You just open up an Excel sheet on your Windows machine or your Mac, and then you jump into it, you type in what you want to type, you can share it with your colleagues. However, its simplicity brings with it some trouble sometimes. This is this is a fake data, but hopefully gives you an idea of things you can encounter when it comes to Excel files. Take for instance the columns. There are duplicate columns that are referring to the same thing. So you have certification 1, certification 2. Whoever created this document, this file probably had something in mind. But in terms of data processing, it doesn't help. Remember, you should have just one column as a variable, have just one row as an observation, and then a single cell should have just a single value. In this case, we should have just certification as just a column. If you look at the column name, so if you look at the do not edit, it's not a helpful column name, or percent allocated. It's not helpful in terms of data analysis. So we need to find a way to fix that. And then another one is the higher dates. It should be in a date format. So you have your year, you have your month, and then you have your day. However, Excel saves as numbers. So when you're reading it, especially when you're reading it into Pandas, so even if you're reading it into R's functions, read R or read Excel, sorry, it comes back as a number. So you need to find a way to convert it back to dates. Look at row 7. It's empty, it's useless. It probably was put in there to create a demarcation. So whoever is reading to say this, oh, look at this 1 to 7, then look at 9 to whatever. But it's useless for analysis. And the column do not edit is completely empty as well. We don't need it, so let's get rid of that. So those are some of the things that data cleaning requires of us before we can get good data that we can use to do our analysis or our dashboards or whatever else we have in mind. All right, so let's jump into the cleaning process. So the very first thing is to clean the names. Sorry about that. Okay. All right, let's just jump on. The very first thing is to clean the names. I'd say clean names is probably the most popular function in Janitor. I don't have any statistics to back it up, but it just looks like the first thing you reach out for when you have names that are funny or not properly formatted. What it does is it converts the names to lowercase. If there are spaces in the column names, it replaces them with underscores. And that's what you're seeing there, where you have your first name, you have your last name, you have your employee status. Everything has been formatted into lowercase. The next step, which we see here, is that we remove those empty rows and completely empty columns. So we don't need them, we get rid of them. The very next step after we've done that is to rename the columns into something that make more sense. So that percent allocated we had earlier on, replace the percent symbol with percent, and then get rid of the extra underscore in full time, rename column. Looking at this, now, as I continue, you'll notice the chaining process. We first started with the data frame, then we change clean names to it, we change remove empty to it, we change rename to it. So if you're staring at it, you can say, okay, first and first is we clean the names, we removed empty, so removed empty rows and columns, then we rename this column. So in rename columns, the parameter is the name you want to change, and then the new name you want to replace it with. Now, after we're done with the replacing of the columns, the next phase is to get rid or sort of simplify the certification column. If you look at the certification, you have 2 columns there. What coalesce does is similar to what you have in SQL. It picks the first non-null value in there. So you can have 10 columns, you can have 20 columns passed to coalesce. it will pick the first non-null value. In this scenario, coalesce by default will take the first column as its destination or its target column name. If, however, you want to put it in a different column, you can pass an argument to the parameter target column name, and then the values will put into a different one. So in this case, if you look at certification, all the values that were null in certification have been replaced by the values in certification 1 that were not null. So down with the coalesce, we remove that extra column of certification 1. We don't need it, so get rid of it. And once we're done with the remove column, the last step is to convert the dates to a proper date format. And that is what the convert Excel date does. Again, the chaining process, the idea that we use verb-like words, the idea that if you stare at it, it should be able to make sense to you when you come back to it months from now and say, okay, what did I do? That's the whole idea. Personally, I even go the extra mile and put comments. Sometimes we say comments are excessive. I feel it's safer to be excessive than not excessive. I'd rather come back tomorrow and look at the verbose rubbish I wrote and say, oh, this is what you were trying to achieve. Why did you put it? I'd rather blame myself than having to come back and say, what does this mean? But the whole idea behind Pyjanitor is you're looking at the API and you're saying, okay, this is what it does. It coalesces, it merges this, it removes this, it renames that, it converts that. Pyjanitor doesn't exist on its own. You can combine it with Pandas. That's the whole idea. It's just wrappers around Pandas functions. We just created some verb-like APIs that will feel simpler. It's opinionated, so we just feel it makes a bit more sense. But the exact process we ran before can be run in this way. You could verbal write a function to do the clean names, but let's just jump over that. We've done the clean names. You drop your nulls in the columns, you drop your nulls in your rows, you rename your columns using your key value pairing. You create or you update your certification column using Pandas combine first. You drop the extraneous column, which is certification 1, and then you convert your higher dates using Pandas to date time. Now, this works, this is fine, but I'm of the opinion, and of course I am biased, that the previous steps are a bit cleaner, a bit easier to understand, less cognitive overload. I should be able to come back months later and look at it and say, yes, I understand, but to an extent, what I did in the previous one compared to this. But again, Pyjanitor works with Pandas functions easily. It interleaves with it. Do not forget, they are nothing more than wrapper functions. There is nothing fantastic. We are not superhuman. We didn't go out of our way to do the West Virginia and write a new library. They just wrap us around Pandas functions just to make life a bit easier. This is another section where you get unclean data, when you get data from the web. So this is the raw data. Now, from the outset, you can see, if you look at the total revenue, you can see that it has amounts in it, and then it has some funny things in bracket, DA and whatever. You have estimates at the front. We need the total revenue to be in numbers so that we can do our analysis or create our charts or whatever it is. If you look at the revenue breakdown, that is even more interesting. It's a combination of the categories and the actual amounts. So you have book sales, 9.1 billion. And right after that, you have box office, some billions. Within that, you have some other categories in a single cell that hard for you to process. It would be best if you had book sales in its own column, you had the amount in its own column, and then you can do your processing. So let's just jump into the cleaning process. The very first step will be change the column name to something more understandable. This is a Pandas function set access. Once you set the access, the next step is to process the text. Now, process text is a function from Pyjanitor, and it's just a wrapper around Pandas numerous string functions. So if you know the name of the column you want to process, you know the function name, and you know the keyword arguments. It's a bit restrictive in the sense that you need to know the keyword arguments if those functions have keyword arguments associated with them. Say a function like replace has keyword arguments associated with it, so you need to put them in. If you're dealing with a function like lower or strip, they don't have keyword arguments with it, so you do not need to pass in keyword arguments. Again, so if you know the column name, you know the function name, you know the keyword arguments, just pass it to process text, it will take care of it for you. So you come to this, you look at it, oh, I'm processing a text. The column is this, the function is this, and these are the parameters that go along with it. So in the case of this one, we want to get rid of those, we'll get rid of the dollar and the estimate in front of that. The next step is to pull the actual number out of it, which is 19.9. And that is where that string function process, in process text, the extract function, with your regular expression, and then ensuring that expand is false. Setting expand to false ensures that that column remains as a series. If it's set as a, well, depending on the number of number of groups in regular expression, if you pass expand, it will treat it as a data frame. But in this case, we need it as a series. So we're done with the processing of the text. We have our total revenue in a number that we can work with. The next point is to move on to the revenue items and sort of split that into individual points. But the first thing we do is just split it using the same process text and the split function. So we'll have it in, we'll have box, we have 245 and all of that. The next step is to explode. I want to believe we're familiar with the explode function in Pandas, which breaks it down into individual rows by itself. And when we're done with that, we can then go back and do another processing where we get rid of the figures in front of that. This is the regular expression that takes care of that. So at this point, if you notice, we just have the book sales, 9 billion, box office, 5.8, and on and on and on. The next step, again, I really want you to just see the whole idea of the chaining process as it goes along. Now, the next step is to deconcatenate. Deconcatenate is an English word where you sort of separate things. And this is the whole idea behind this. So you have your column name, you have the separator, you have your new column names, and then the preserved position is the points where revenue items was earlier on, get rid of it, and in that same location, replace it with the new values. So we have revenue category that contains book sales, and then we have revenue that contains the amount. And then the next step after we've done all of that is to get rid of rows that are useless to us. We just want the rows in revenue that contain billions and millions. The query function in Pandas takes care of that for us. And so the next point here is get rid of white space, convert it to lowercase, and then use the replace function in Pandas, which is a very powerful function. Sometimes it's underappreciated, but does a whole lot of work pretty easily. So in this case, we want to categorize the revenue categories. So take, for instance, you have, if that column revenue category contains DVDs or it contains home video or video rentals, want to replace that with home video entertainment. That is a categorization, and this is what the replace function here helps us to achieve. Now, after we're done with that, we process the text again. This time around, we've taken care of total revenue, we've taken care of revenue category, we want to know fixed revenue so that we'll have just the numbers. Now, revenue is a mix of billions and millions. We need to find a way to convert it, not just to numbers, but capture it in a way that we can recognize the billions and the millions. Total revenue is all billions, so we just left it as 19.9, we didn't touch it, but we need to find a way to edit revenue. So the B represents billion, the M represents millions. Now, we pass it again to process text using the replace function, where we first we've gotten rid of the alien, so we just have the B and the M, and then we say if it contains a B, if it contains a B, converts, just get rid of it. But if it contains an M, put an E minus 3. The whole idea of this E minus 3 is 10 raised to the power minus 3, so that we can normalize everything in the billion formats. Once we get this, we can then do a transform using Pandas to numeric to convert the entire data frame. So this runs across the entire data frame. And if it hits a column that it doesn't think fits into a numeric format, we're telling it ignore that. So it will leave that column as it is. And then if you are keen on resetting your index, you can reset by dropping through. So if we have a look at the data, we can see that we have our total revenue. You can run the D types on it. So we have a total revenue, we have our categories in a separate column, we have a revenue in a separate column. There is still more to be done here, but as I said, data cleaning is boring, is intensive, and my aim is not to make it any more boring. If you look at the franchise, you could probably split the middle earth and a lot of rings. So you could make a lot of rings like a category and then make middle earth a subcategory. There are various opportunities here. You could turn some of them to categorical columns. You could say, yeah, created, turn into a categorical column if you so desire. There are options here. But data cleaning is a never-ending process, and I think one of the key parts is to know when to stop, or else you will be like a recursion that never ends. So these two examples that I've presented so far capture some of the Pyjanitor idea. Use chaining as much as you can. Use verbs that use APIs that have a verb-like expression so that when you see them, you can sort of tell what it does. We don't get it perfect. We try to, and that's why I have at the end this Clarion Call. But we try as much as possible to make it as understandable and easy to use as possible. Now, Pyjanitor is not just for cleaning, it extends into transformations, making some things that are common pretty simple by wrapping them up into something. And we take some of our ideas, more often than not, we take our ideas from the R verse. One of the functions there is a pivot longer function, which is basically converting data from a wide format to a long format. The examples here adapted from our data table and Pandas melt. So the first one here is taken directly from the Pandas documentation. So you have this data frame and you want to move your height and your weight into a single variable, say a dimension. You can do this with Pandas melts. You can also do it with pivot longer. Pivot longer basically just wraps around Pandas melts and Pandas concats. Again, they are just wrappers around Pandas functions. Nothing spectacular. Just make your life easy and move on. So basically for this one, we say, what is the index first and the last? And then the default values will be variable and value. So we have one column for height and weights, and then you have our values. If you're lazy like me, and I have to admit I'm lazy, which is why I use Python, because it allows me to be lazy at scale efficiently. The index allows you to use a particular syntax. This syntax is taken from the shell programming languages where you have an asterisk and it follows on. So in this particular scenario, we're saying, give me index should be only the words that end with st. Now, the caveat is that your name should be clean. Imagine you have column names that have an asterisk in it. That's only spelling trouble. So one of the caveats is that your column name should be clean. So with this, I'm saying, give me, for the index, I only want columns that end with st. And because I'm lazy, I don't want to type all of first and last. It takes care of that for me. Say I want the variable to have good descriptive names. I set the index and I say names to, so this is what the new names will be. And then I set the values to, this is what the new values will be. Again, if you're familiar with pivot longer in tidyverse, this shouldn't be unfamiliar to you. Again, if I want it in a particular sorted format, I want to sort by appearance where if you look at the original data frame, John came before Mary. So in this case, it's going to be John, John, and Mary, Mary. So sort by appearance, you said this is true. You also have the option where if you don't want to lose the index, you can just say ignore index is equal to false, and then the original index is retained. Same with Pandas melt is retained with your data frame. So let's take it a step further. Let's say we have something like this is pulled from the R data table documentation. You have multiple names in your column. So if you look at that, you have sepal.length. So you have sepal, which is a part. You have length, which is like a dimension. And you have that for the width and the length and the width, and then you have your species. And we want the sepal and the petal to be in one column, which is going to name it as parts, and we want the length and the width to be in another column, which can name that as dimension. With pivot longer, it is simple. We pass what we need again within a simple form to the pivot longer. Set your index as species. Names too, because we are working with two columns. One that we're splitting into two columns, we'll give it two names. We have a part and a dimension. It could be a tuple, it could be a list. What is the separator? A separator in this case is the dots. We already know what sub-appearance does, and so it takes care of that. So everything is in its own column. If we are interested in keeping just a part of the column as a header, now initially it was sepal.length, sepal.width, but we want to keep the sepal and the petal as a header, and then keep the dimensions as keep the length and the width as a dimension. We take it a step further within the same pivot longer face. Use a dot value. So look at this. We have sepal, then length. Dot value will be paired with sepal, and so it will stay as a header, whilst the length is associated with dimension, and then it goes in as a column. If you look at the example beneath, we want to keep the length, the dimensions as a header, and then the parts become columns. The same concept applies. You take the dot value, in this case, will paired. You just have to swap it. The dot values will paired with the lengths or the dimensions, and then the parts will paired with sepal and petal. Again, the idea is if your data or if your columns have a particular pattern, take advantage of that pattern and pass it into your into pivot longer. Pandas has melted as white along. White along is a bit limiting in the sense that it's a fantastic function. It's just a bit limited in the sense that you need to use prefixes. With this particular example, you could easily swap the columns. So swap length in front of sepal, or swap width in front of petal, and then pass it into white along. But with this, you don't need to worry about those constructs. It's relatively simple in your head what you need to do. Oh, there's a pattern. This is how it looks. Throw it into it and let it worry about the drama. With white along, you have to be cautious about duplicate indexes. With this, you don't need to worry about indexes. In fact, with pivot longer, you don't even need to pass in, if depending on your data, you don't even need to pass an index to your pivot longer. You can say index is equal to none, and it will take your existing index as the function, as the values, and run with it. Again, abstraction, trying to make it as simple as possible for you. And then when you come back and you look at your data, you say, this is what we were trying to do. Fantastic. Move on. The other option, or the other function I'm going to look at is, this is where this is, my apologies. So take, for instance, that there is no defined separator. The previous ones were simple. You had the dots in between. This doesn't have a dot. Look at that underscore. If you use the underscore, you're going to split new SPM5564 into 3 formats. This data is directly from the World Health Organization. So imagine splitting this and you get 3 columns, whereas if you split the other column, you get 2 columns. So names separator won't help us here. What will help us here is names pattern. Names pattern is basically a regex function. You pass in the regex function with your names too. In this case, you want to split it into 3 values. You have your diagnosis, you have your gender, you have your age. Again, is there a pattern? Can I take advantage of that pattern? Dump it into pivot longer to take care of it for you. Abstraction, make your life as easy as possible. Okay. So the other part is, another function is complete. It's also from Pyjanitor. It's also from R, tidy R specifically, where you want to expose missing values. So if you look at this particular one, you have ID, year, and semester. If you look at that, you will notice that there's an ID 1, the year 2000, and semester 2 is missing in this data. You want to make them obvious. For some reason, you want to draw a graph and you need everything to appear. It's so common that people do reindex. Sometimes you can do a stack on stack. We believe that with the completes, you take away the abstraction. With reindex, one of the disadvantages of reindex is that if you have duplicates, in your index, you cannot reindex. Same thing goes for stack or unstack. If there's a duplicate, if the index has duplicates, it won't be able to unstack. This is just abstracts it for you. And again, they're simple functions. It's a wrapper around where you just explode it. We use a function from NumPy mesh grid to generate the functions, to generate the unique columns, and then we do a left merge. That's all it is. That's why we say open source is beautiful. You can always see what is done in the background. So with this, it exposes everything. If you don't want to expose all of the data, you just want to use only data that exists within it, you can just wrap them around in the brackets and it will not go beyond that. So it only expose missing data that exists in the data frame. Let's say I want to now do this, but for each group, and that is where the by comes into play. So you do it for each ID. Let's say I want to expand the years to 2003, pass a dictionary. The key of the dictionary must be a column that exists in that data frame, or else you get an error message. And then the values will reference the column name, which is the key in this instance. So you can either use an anonymous function or a lambda function, or just plainly use the df to refer to it. What if I want to expand the semester as well? You can add as many values as you want to the dictionary, as long as those names exist within the data frame. What if I want to do this, expand the year, but within an ID, which is a group way? Underneath the hood is nothing more than a group by dot apply. We just find a way to use it in a bit more efficient way. Instead of running the apply on the entire process, we sort of segment it so that it's a bit more efficient. But that is all it is under the hood. Again, try and make the functions as simple as possible, understandable, easy to use. The other part is an if else. Pandas has mp.select. Pandas has, sorry, I said pandas. NumPy has mp.select. Pandas has where and the mask. mp.select is amazing. It's great. It's fantastic. Sometimes if you're using extension arrays, you will lose it because it will dump down into NumPy arrays, which might not be helpful sometimes. And NumPy select can be a bit convoluted depending on the way it is. If you're going to use it in a chaining form, it might not be really helpful. Your best bet is to write your function outside this and then come back in there. Wufil, Pandas, Pyjanitor should have a function that covers this scenario, and this is where the case1 function comes into play. If you're familiar with SQL, case1, if you're familiar with tidyr, case1, in our data table, it's called if else. But the concept is taken from our data table. Again, it's a wrapper around Pandas function. We're not doing anything fantastic. We just saw something that was wonderful somewhere and we said, hey, import it. And that's all it does. So basically, the concept, if you're familiar with case1, is the same thing. Your first condition, your first entry will be a condition. If that condition is true, this is the value. If that condition is true, this is the value. If the condition is true, you can write as many conditions as you want. Just make the scenario for a default. So condition true, condition true, condition true, false. And then give it a column name you want to replace it with. You can use your regular pandas function as you see at the top. You can also use an English, let me say English expression. You can use an expression. If your expression can be evaluated by pd.eval, then you can pass it in as a condition. This is only applicable to the condition section. If you're going to pass in a value, you can use pd.eval. You need to pass in a value, or you pass in your df.something or your lambda df. You can use anonymous functions. But for the conditions, you can use an expression, which in some scenarios can make your processing a bit cleaner. So if you look at this, age is less than 10, this is going to hit back on the source data frame. So it doesn't matter if you're chaining this down to something you've done like 10 queries down or 10 queries up, it will refer to the existing data frame and take care of it for you. So age is less than 10, make it a baby. If it's between 10 and 20, make it a kid. If it doesn't meet any of these conditions, make it a grandpa, and then the column name is elderly. Again, under the hood, this is just a wrapper around pandas mask function, pandas a series of mask, nothing more than that. Few checks here to ensure that things work fine, lots of extensive tests in the background. But again, it's just a wrapper to make it easy to use. Now, this is just an example. A much easier, a much more performance way to solve this would be to use pandas cuts. Since we're working within bins, it's a bit much easier and faster. Again, this is just an example to show you how, if you have lots of conditions, if you have conditions, you can do this. Again, if you have lots of conditions, sometimes it might even be better to just write one data frame with so many conditions and then do a merge, a left merge. The scenarios differ. It depends on what you want to achieve. But again, this is just to show you how you can make conditions a bit simpler within pandas. I've brought a lot on all of this. The very last one is something that speaks to me because I work in data engineering, and sometimes you always want to filter data as much as possible. And as much as well, you just want to look for something that is simple. And this is one of those things that appeals to me, reading from the command line. I first saw it with data table and I was impressed by that. And I'm like, okay, is it possible to bring this into Pyjanitor? And luckily, we had someone who contributed this function in Pyjanitor. It is nothing more than a wrapper around subprocess.run. That is all it is, a wrapper. It gives you some useful error messages, but that is all it is. It is dependent on you to understand shell language, whichever platform you're working on. So let's start with this example. This is, you're trying to read the data from a zip file. Pandas has a limitation where you cannot read more than, the zip has to contain just one zip file. But your file might contain more than one. You just want to tap into that. With the read command line, all it just does is take that condition, pass it to unzip, and then it gives you your data. Again, you are familiar with your shell commands. You probably are a guru. I'm not a guru. I just know those basic functions. If I want to use unzip, trust me, I'll have to type it in the man pages or use a TLDL to remember how to use it. But once you know what function you want to use, take it in, dump it in there, and you're good to go. Again, you're just trying to get some results and you're moving on. The other aspect that appeals to me about reading from the shell or the command line is you can pre-filter and pre-filter efficiently. So take this example of the US counts. It's about 2 million rows, which is fair enough. If you have a very powerful machine, you can dump it in that. However, if you want to filter this down, if you read this into Pandas, it takes in the entire data, which is not helpful because all I'm interested in is just the California data. With the read CSV, you can use your grep. If you are familiar with XSV, it's a Rust shell implementation. You can use that as well. So this does. I run this on a Mac, so that's why I'm using a G grep. The G grep is faster than the default on Mac. You could run it with the XSV. Is also another function that works with shell commands, tabular data on the shell. Mock, which is your enhanced version of awk, it also helps with that as well. Again, there are different options. If you are a super user of the shell language, why restrict yourself? Take advantage of it, prune your data down as much as possible. So if we check the speeds for this, if you look at that when you run it on Pandas, where you're pulling the entire thing, you're running on 1.27 seconds, whereas if you run it, now this, I try to put this there so that we can see the comparison, but if you look at that for the grep, the beauty of that is you first pick the head, which is the column names, and then you just grep for the values you want. It's about 135. If you use the rip grep, which is faster, it's a Rust implementation, so I can't remember his name, Bon Sushi or something. He made it pretty faster than your usual grep. Runs it down 25. You use the XSV 463, your mock. You can see that they pre-filter before you load in your data. And if you look at the memory consumption, there is 100 megabyte might seem small, but imagine that on much larger data. Your memory usage is improved a bit. Again, Pyjanitor is nothing more than wrappers around Pandas functions, Python functions. The whole idea is a simple API that makes sense and you can make use of. The Clarion Call is contributions are welcome. I was looking for a way to contribute to open source because I use Pandas a lot. And then I saw Pyjanitor. I was impressed with what we're trying to achieve and I jumped in there. It has helped me to improve my knowledge. The first time I used PyTest was with Pyjanitor. The first time I used Hypothesis was with Pyjanitor. My knowledge of infrastructure has improved. GitHub Actions, it's not a foreign term to me. It makes more sense. I understand what it's trying to achieve because I am involved in a project. I even appreciate more documentation. You see people review your code and tell you, no, this is how you should put it, 79 lines, semantic arrangements. It makes more sense. So contributions are welcome, documentation, code. You probably see a name there that you feel doesn't make sense or you feel could be done better, or you feel could be done more efficiently. Infrastructure-wise, reviews, feedbacks, please. It's open source. It's a welcoming community. They welcomed me. They've treated me great. I haven't seen the Pyjanitor team treat anybody awfully. If there's such a scenario, please let us know. We'll try and rectify it. So please, contributions, corrections. And if you feel there are things you want to mention or you good or bad criticism, please bring it on. I don't think there should be anything like only good criticism. Bring everything to the table. The only way we improve is by getting feedback. So yeah, I think I have ranted for so long, I should just mute my mic. Hope this made sense. Thank you again for listening. Thank you for listening to this boring conversation. Thank you.
Thanks so much, Sam. That was an awesome presentation. So I think as a data engineer, I need to take a look at Pyjanitor and, reap all the rewards and the hard work that you've put into it, along with everyone else on the team. So we've actually got a few questions. So before we jump onto the questions, so if anybody else has more questions, please add them to the live stream. It's in the YouTube comment section or the live chat section. So just one more thing, just before we jump over there, social media, like you can find us on meetup.com, the PyData organization. We're on Twitter or LinkedIn, YouTube, as well as the Slack workspace. So yeah, you can find that link in the meetup event. So Sam, I think we'll head to some of the questions.
Yeah. Okay. How long has Sam been an open source dev? And I've been an open source dev for over a year. Day to day, when I get the chance, so I've got 2 kids. So that gives you an idea of how my day to day can be. Drop them off in the school in the morning, pick them back from school in the afternoon. And you also have to make time for work because you have to pay the bills. So more often than not, I get the free time in the evenings and on weekends. Before I got the job, I had loads of time to spend to review code, to make contributions, to look at the documentation, check if there were any failing tests. And if there were things I didn't understand, I'd reach out to the rest of the team. Hey, we're having an error here. Could you please tell me how to fix it? There was a time I jumped the gun. So I'm a believer in there's positives and negatives to everything. There was a time I jumped the gun. So there was a period where Pandas wasn't relying on XLRD because of the deprecation for XLSX. So we had some functions that were failing in Pyjanitor, and I just took the unilateral decision to add OpenPyXL to the list of requirements. Somebody brought it up and said, look, that was wrong. I did not go hard-headed and say, blah. I understood where he was coming from. I understood why he did it. And I said, I apologized. And I said, look, thanks for this correction. I won't make that mistake again. So going forward, if I want to fix something, if I notice something wrong, I mention it to the team and say, hey, look, this is what's going on. I feel we should add this or we should remove that. Again, it's about not abusing your power. And at that point, I did abuse my power. So it was something I learned, and I can only learn this by interaction, by working with other people. It's an open source environment. People doing this, it's a labor of love. So as much as possible, we need to respect each other. But so far, it's been fun. It's been fine. I've been trying. I'm working at the moment. I'm working on a function called conditional join. In our data table, is known as a non-equi join, where you can use non-equis in your merge. So I've been working on that. We already have something existing, but in my head, it can be better, it can be more efficient, especially when you're working with equality signs. So I don't want to talk further than that, but those are some of the things I'm working on. And we have colleagues that are working on other things as well. We're trying to work on our documentation to make it better and more informative and clearer. I hope that answers the question. How faithful is Pyjanitor to the R package? As faithful as possible, but remember that our first love is Python. So there are things we do that has to respect the Python formats so that users of Python will be able to roll with it. If you're coming from, take for instance, let's take a typical example of the pivot longer. If you're coming in from R, you're probably familiar with it in the tidyr package. In the tidyr package, you don't have an index per se. Intuitively, they have a way of finding out what the index is. Within there, you have something like drop NA. You have some other functions in there. In Pyjanitor, we felt let's keep it as simple as possible and understandable to existing users of Pandas. When I wrote the function, looking back, I took the idea of the dot value from R. Sometimes I ask myself, did I make the right decision? Should I have used stub names so that people who are familiar with wide to long can say, oh, stub names makes more sense. We understand where this is coming from. Decisions. But as much as possible, we'll try to take the idea from R, that the clean names, it's totally from the janitor package. We implemented it within Python. So if you see clean names in R, if you come to Pyjanitor, you see clean names, you have a very good idea that, okay, they do just about the same thing. I don't know 100% about what happens in R, but it's just about the same thing. Recently, we were told somebody puts an issue about make clean names, which we don't have in R. We don't have in Python, but it exists in R's janitor, which is a great one. That's a good way to contribute, and it's welcome. Anybody that wants to pick that up, please go ahead and do so. What else? With Pyjanitor being so reliant on Pandas under the hood, how do you deal with bugs introduced in new Pandas releases which break Pyjanitor's function? That's the problem with dependencies. We can't run away from it. It's a bit of a digression, but it's one of the things that makes our data table appealing to purists in a way. It's super fast, it's super efficient, and it has zero dependencies. And they have this backward compatibility thing that goes on with it. It's great, it's fantastic. In Pandas, we don't have that. So if something breaks in Pandas, we will bear the brunt. If a bug pops up in Pandas and we are aware of it, somebody raises an issue, what we'll probably do most likely is we'll have a discussion on it and then probably make a note in the documentation or put a warning in the code. We'll have to discuss on that and say which is the best way to handle this particular bug, pending when it is fixed in Pyjanitor. So pending when it is fixed in Pandas. So let's say there's one that is even a minor issue. In Pandas, sometimes you can compare extension arrays with numpy arrays to give you a numpy array, and sometimes they give you a Boolean array. Boolean array is a Pandas extension array. Now, depending on your processing, it would affect how you are treating it. So if you're dealing with a numpy array, a numpy array doesn't recognize an extension array, so it will fail and give you an error like slices, blah blah blah, only works with integers. So if you notice that you raise an issue for us, please do raise an issue. We will try and find a way to fix it and make it more adaptable. Which other questions am I missing here? I think that's all the questions, I think. Yeah.
Awesome. Well, we'll just see if there's any more questions. Double check. I think that's about it in terms of questions. So, Sam, thank you so much for coming on. Thank you for sharing, all this knowledge about Pyjanitor, and thank you for contributing to the community, and giving back and making data more fun and easier to work with.
Thank you for having me. It's been a pleasure and a blast. Thank you.
No worries. Thanks everyone who tuned in, and you'll be able to view this talk over and over on YouTube. Cool. Thank you.